All right, number 9 from board work. We have a car. A police car finds a 90-meter long skid mark. The coefficient of friction is 0.5. Estimate the speed of the car when the brakes were applied. So this is sort of a two-part thing. So you have a dynamics part where you're going to do a free body diagram and net force equation. And then you're going to have kinematics to figure out the speed. So first, the idea of the first part, you're going to have to find the acceleration using Newton's laws and stuff. Okay. So if I told you the acceleration and you knew the displacement and that the final velocity was 0, then you could solve it just using kinematics. So what we're going to do is we're just going to do an easy free body diagram here. And the only force acting on this thing is the force of friction opposing it, at least horizontally. And of course we have the normal force of the road up and its weight down, being exerted by the earth. So the net force in the x direction is, and we need to assign directions, let's make to the right, which is the direction of motion, positive, let's make up positive. So the net force is just minus FF, since we made to the right positive, right?
Yes.
So then the next step was just set it equal to Newton's second law, F equals ma in the x direction. And remember, the equation for force of friction is force normal times mu. That would be mu k since it's skidding, right? And in this case, the y equation would be net force y equals Fn minus mg. In this case, that's going to add up to 0 because there's no acceleration in the y direction. So Fn is going to equal mg. So we can just replace mg for Fn. That's not always the case, but in this problem it is. So that means the m's will cancel. And the acceleration will simply equal minus, which we expect, g mu. Okay. And we know that from the problem, they tell us that's 0.5. And then we all know g is 9.8. So now it just becomes a kinematic problem. So you have V final, because it's at the end of the skid mark, is 0. And they want to know V initial in the problem. And we have acceleration, and we must know one more thing, and that's displacement is 90. So we would use VF squared equals VO squared plus, right. Yep. And then you solve for VO.